Imagine gazing at a sunset, the sky awash not in familiar oranges and reds, but in hues of dusty rose and pale violet. The Martian atmosphere, thin and alien, scatters sunlight in a way that creates these surreal colors, painting a picture that is both haunting and beautiful. Above you, two small moons, Phobos and Deimos, trace their paths across the starry expanse. These moons, named after the Greek gods of fear and terror, add to the mystique of the Martian night, their irregular shapes and rapid orbits unlike anything seen from Earth. This is Mars, a planet that has captivated humanity's imagination for centuries, and now, the dream of living on this red world is closer than ever. From ancient astronomers who first charted its course across the sky to modern scientists who send rovers to explore its surface, Mars has always been a source of wonder and inspiration. The allure of Mars is undeniable. Its barren landscapes, towering volcanoes and vast canyons call out to the explorer in all of us. The idea of setting foot on a new world, of being part of a pioneering mission, is a powerful draw. It's a chance to explore a new world, to stand on ground untouched by human feet. Imagine the thrill of that first step, the sense of accomplishment and the realization that you are part of something much larger than yourself. The spirit of adventure, the desire to push the boundaries of what's possible, these are deeply ingrained in our nature. From the earliest days of human history, we have always sought to explore the unknown, to see what lies beyond the next horizon. Mars offers a blank canvas, a chance to build a new society, to learn from our past mistakes and create a better future. Imagine cities designed with sustainability in mind, communities that prioritize cooperation and innovation. But it's not just about adventure. The scientific opportunities on Mars are immense. Studying its geology, climate, and potential for past life can teach us more about our own planet and the processes that shaped it. Establishing a presence on Mars is also about ensuring humanity's long-term survival. By becoming a multiplanetary species, we reduce the risk of extinction from global catastrophes. Earth, for all its beauty, is facing challenges: climate change, resource depletion, and the ever-present risk of unforeseen disasters. These issues highlight the need for a backup plan, a place where humanity can start anew if necessary. Mars represents an insurance policy, a backup plan for our species. It's a place where we can apply the lessons learned on Earth to create a more resilient and sustainable society. The journey to Mars will be arduous, fraught with challenges and setbacks. The distance, the harsh environment, and the technical hurdles are significant, but they are not insurmountable. Yet the rewards are immeasurable. The scientific discoveries, the technological advancements, and the inspiration provided to future generations are worth the effort. The chance to explore a new world, to expand our understanding of the universe, and to secure the future of humanity, these are the dreams that fuel our Martian ambitions. Mars beckons us with the promise of adventure, discovery, and the hope of a new beginning. Mars may beckon, but it's no tropical paradise. The red planet presents a range of formidable challenges to any hope of human habitation. Its environment is harsh, unforgiving, and utterly alien compared to our earthly cradle. One of the most pressing issues is the thin Martian atmosphere, about 1% the density of Earth's. This thin air offers little protection from the sun's harmful radiation, and it's incapable of supporting human life without specialized breathing apparatus. Then there's the temperature, averaging a frigid -81 degrees Fahrenheit, or -63 degrees Celsius. While temperatures can rise near the equator during the day, Martian nights are brutally cold. These extreme temperatures make liquid water scarce, existing primarily as ice at the poles or locked away beneath the surface. Finally, we have the issue of Martian soil. Unlike Earth's life-sustaining soil, Martian regolith is low in nutrients and contains toxic perchlorates. This presents a significant obstacle to growing food on the red planet. Overcoming these challenges will require ingenuity, resourcefulness, and a healthy dose of human determination. But with careful planning and innovative solutions, we can transform these obstacles into opportunities, paving the way for a sustainable Martian civilization. Constructing homes on Mars presents a unique set of challenges, demanding innovative solutions that leverage local resources and prioritize sustainability. The harsh environment, with its thin atmosphere and high radiation levels, requires us to think outside the box. Traditional building materials are impractical to transport en masse from Earth, given the immense cost and logistical hurdles. Instead, we must turn to the red planet itself for our construction needs, utilizing what Mars has to offer. One promising solution is 3D printing using Martian regolith. This abundant material with proper processing can be mixed with binding agents to create strong, durable structures. The regolith, essentially the Martian soil, is rich in minerals that can be harnessed for construction. Imagine massive 3D printers resembling robotic arms, tirelessly layering Martian concrete to erect homes, laboratories, and even entire neighborhoods. These printers could operate autonomously, working around the clock to build the infrastructure needed for human settlement. This technology not only reduces the need for transporting materials from Earth, but also allows for rapid construction, essential for establishing a foothold on Mars. The versatility of 3D printing means we can create complex structures tailored to the unique Martian environment. To protect inhabitants from radiation and the thin atmosphere, Martian habitats will likely be partially submerged underground or enclosed within protective domes. These subterranean homes can provide natural insulation against the extreme temperatures on the surface. Protective domes, on the other hand, could be constructed from transparent, radiation-resistant materials, allowing sunlight to penetrate while shielding inhabitants from harmful rays. These domes would create a greenhouse effect, helping to maintain a stable internal climate. Inside these Martian homes, advanced life support systems will be crucial. Oxygen generated from splitting water molecules or extracted from the Martian atmosphere will be carefully circulated. This process, known as electrolysis, can provide a steady supply of breathable air. Temperature control will be paramount, maintaining a comfortable living environment despite the extreme external conditions. Advanced climate control systems will regulate the internal temperature, ensuring that the habitat remains livable. Building a home on Mars will be less about replicating Earth and more about adapting to a new environment. These dwellings will be a testament to human ingenuity, designed not just for survival, but for creating a comfortable and thriving Martian life. The interiors of Martian homes will be equipped with all the necessary amenities to support daily life. From hydroponic gardens for growing food to advanced waste recycling systems, every aspect of life on Mars will be carefully planned and executed. The goal is to create a self-sustaining environment where humans can live and work comfortably. This includes not only the physical structures but also the psychological well-being of the inhabitants, with communal spaces and recreational areas. The journey to building a home on Mars is a monumental task, but with each step, we move closer to making it a reality. These innovative solutions are just the beginning of what promises to be an exciting new chapter in human exploration and habitation. These dwellings will be a testament to human ingenuity, designed not just for survival, but for creating a comfortable and thriving Martian life. The future of Martian housing is bright, filled with endless possibilities and the promise of a new home for humanity. Establishing a permanent human presence on Mars hinges on creating a self-sustaining life support system. This is not just a matter of survival, but of thriving in an environment that is vastly different from Earth. The challenges are immense, but so are the opportunities for innovation and discovery. This involves tackling the crucial challenges of water access, food production, and developing reliable transportation systems for traversing the Martian landscape. Each of these elements is a piece of the puzzle that, when put together, will allow humans to live and work on Mars for extended periods. Water is the lifeblood of any civilization, and Mars, while seemingly arid, holds promising reserves. The presence of water is not just about drinking, it's about supporting all aspects of life, from agriculture to hygiene. Subsurface ice deposits, particularly in the northern plains, represent a potential water source. These ice deposits could be tapped into using advanced drilling techniques, and once extracted, the water can be purified and used for various purposes. Extracting this ice and purifying it for consumption will be a primary focus. This process will involve not only the physical extraction of ice but also the development of efficient purification systems to ensure the water is safe for human use. With water secured, the next challenge is food. Food production on Mars will require innovative solutions to overcome the lack of fertile soil and the harsh environmental conditions. Traditional agriculture on Mars is difficult due to the toxic soil and harsh environment. The Martian soil contains perchlorates which are harmful to humans and plants, making it unsuitable for conventional farming methods. Instead, we'll rely on controlled environment agriculture such as hydroponics and aeroponics. These methods allow us to grow plants without soil, using nutrient-rich water or mist to deliver essential nutrients directly to the plant roots. These methods use less water and space, allowing us to grow crops efficiently within enclosed, climate-controlled environments. This not only maximizes the use of available resources but also protects the crops from the harsh Martian climate. Transportation on Mars presents its own set of challenges. The vast distances and rugged terrain require robust and reliable transportation systems to ensure the movement of people and goods. While rovers will be vital for exploration and resource gathering, more efficient transportation systems will be needed for long-distance travel and transporting goods. These systems will need to be designed to handle the unique conditions of the Martian environment. Maglev trains running on elevated tracks to avoid obstacles could provide high-speed transportation across the Martian plains. These trains would use magnetic levitation to reduce friction, allowing for faster and more efficient travel. These logistical hurdles, while significant, are not insurmountable. With the right technology and ingenuity, we can develop solutions that will enable us to overcome these challenges and establish a thriving human presence on Mars. By combining human ingenuity with advanced technology, we can create a closed-loop life support system on Mars, enabling us to thrive on a planet seemingly hostile to life. This system will recycle air, water, and waste, creating a sustainable environment for future generations.